Welcome to NASA Edge.
An inside and outside look at all things NASA.
Hey, we're at ATK in
Promontory, Utah.
and behind us is a development motor, or DM1.
Yes, for the Ares 1's first stage rocket.
And a lot of the ATK guys behind us are getting ready for this first test firing.
To sort of really understand what's going on for this test, we had an opportunity yesterday to talk to some NASA engineers and some ATK engineers.
Yeah, how do we go about doing a test like this?
I want to know.
Especially the structure. Why is it horizontal test as opposed to a vertical test? What kind of propulsion systems are we using here?
Yeah, it's just a pass-fail thing.
What kind of data are they going to be collecting?
These guys really know their stuff, so stick around and you'll get the answers to those questions.
And we'll come back right after the test.
Yes, from a safe distance, mind you.
Absolutely.
Yes, we're here at what I consider to be a very safe distance from the test tomorrow for the Ares 1 5-stage motor, and we're here with Deborah. So, Deborah, what can you tell us about what we're going to experience tomorrow?
What you're going to see tomorrow is a lot of fire and smoke, because they actually ignite this 150-foot motor that has 1.5 million pounds of solid rocket fuel that burns for a little over 2 minutes. So we would get to see this entire motor go through its whole burning operational phase.
It's like a big Roman candle.
It's a huge Roman candle.
What do we have behind us?
We have the first static test motor for the Ares program for NASA. So
You're feeling kind of stiff right now. You okay? You
all right. There's no bit.
Who wouldn't be nervous when you're standing behind the nozzle of a SRB of massive proportion?
Are we safe right here? Are we okay?
I'm sure that we're safe, but I get a little nervous sometimes too.
Do you? Okay. All right.
Not as bad as when you crawl inside that thing and you're surrounded by all that 1.5 million pounds of propellant just surrounded.
Whoa. Time it. You actually crawl inside that with the propellant there?
People do. I've been up there a few times. So.
Did you lose a bet, inter-office bet or something? Is that how you end up crawling?
One time I did lose a bet. We all drew straws on who has to be the one to crawl in there.
I'm looking at this mirror. We had this mirror in front of us, and then what's that silver structure in the back of the solid rocket motor?
All right, we have this new structure. It's called the skirt side load fixture. Pre-test and post-test, we're going to apply side force plus or minus 200,000 pounds, and then we get a better idea of what the static test is doing.
The purpose of that is because when Ares 1 eventually takes off, that vehicle will be rolling.
Right, since there's only one stick on the Ares vehicles, then roll is a concern. So we need to know how much roll and be able to design for that.
Okay. This is a 5-segment SRB. That's a derivative of the shuttle SRB. So what are some of the improvements that you made on this particular motor compared to the...
We've made the nozzle a little bigger, open the hole, the throat that you see there. We're trying to control the propellant, the thrust, the pressure inside that motor.
Right.
The propellant burns a little hotter, so you thought it was hot enough before, but now we stand here, it's getting a little hotter.
Okay.
Give us more power, some more thrust.
Propellant geometry the same as the shuttle SRBs?
There are some changes to it.
Okay.
Some minor changes.
Classified?
Yeah. Geometry questions are always compelling for the program.
The propellant the formulation's a little bit different to get a little bit different burn rate.
Like, what is the formula?
I cannot tell you. All right, well,
I gave it a shot.
But there are a few things that are known. There is ammonium perchlorate, and there's aluminum, there's iron oxide, and what it does is when you mix all this together with other things, it feels very much like an eraser, like the end of an actual lead pencil eraser.
Sure, I'm the installation subsystem manager for the Ares first stage for Marshall Space Flight Center.
That's an impressive title.
It's much too long, though.
That's good.
I need a shorter one.
I say just go with Inspector 12. There you go. You heard it here first. Now, where do you get insulation that can handle that kind of thing? Just down at like Lowe's or?
Well, we thought about going with Lowe's, but they didn't have enough capacity to help us, so we actually get it from our primary contractor in California, which is Kirkhill Rubber Company.
And why does the burn from the top of the rocket down as opposed from the bottom to the top?
Well, you've got your igniter, and it's because a lot of it is your pressure drop as it goes down the bore of the cylinder. So your igniter is always at the head, and because you're pushing the gases out, you've got to start somewhere, of course. You have to ignite it from there, and then it starts to burn and erode through all the propellant, and then your gases get propelled out the backside of the nozzle.
Is this like a standard igniter that you have like on a gas grill, or is this much more?
It's similar, but a lot bigger and a lot more powerful.
That makes sense considering the scope of this test. Is it a a graded test, or is it a pass-fail? I mean, what makes this a successful test?
Depends on the objective, but yes, a lot of it's just pass-fail, but a lot of the other things are, do we meet the ranges of the certain, gauges and temperatures that we're looking for and pressure measurements. So pressure is a big one.
Now, when you have this long solid rocket motor, I mean, what kind of structure do you need in place to hold it? I mean, it's got to be a pretty strong structure.
Yeah, it does. We have a forward test stand, which the primary role on the forward test stand is to measure the axial thrust.
Okay.
That supports the forward end. Then we've got an aft test stand that measures primarily the lateral or side force that the nozzle vectoring causes, and that supports the back end.
Why this test is a horizontal static test as opposed to the rocket being vertical?
Well, it'd be kind of hard to put it vertically because, first of all, we've got a lot of instrumentation on it. We're getting data, we're getting temperature data, pressure data, strain gauge data, accelerometer data, load data.
Got all that?
That's a lot of data.
There's a lot of data, and in order to do that, it's much easier to put it in horizontal, and also because you need to have it so it doesn't go anywhere. You want it to stay in one place when you fire this thing. So the support system is very strong in order to keep it so that wherever you are still at a safe distance.
And plus, you don't get the cool mountain carvings that you get after one of these cool tests.
That's very true. They actually fire it into the back of this mountain. And as you can see, there's a fire break there as well, because you'll get a huge plume that goes out and a lot of smoke that comes out. And it's a great show, and it's a very interesting test.
How much thrust are we looking at for this particular review?
We're looking at 3.6 million pounds of thrust. Wow. That's a lot.
Wow, and what kind of temperatures are we looking at?
Plume temperature is about 6,000 degrees Fahrenheit.
6,000 degrees Fahrenheit.
So that's pretty intense heat.
It is. It's intense.
Yeah, I mean, now I'm wondering.
It's a lot of magnetosference.
Yeah, well, because like the sun lets off, the solar flares, creates magnetosference. If this burns at approximately 2/3 the temperature of the surface of the sun, are we going to get any solar flare type experiences from this test?
Well, I don't think you're going to have to worry about that because that's internal combustion.
Now, I've noticed I have some safety concerns too. What happens with this massive blast that takes place? It looks like you've created quite a mess for yourself over here. Is there any shot of maybe some s'mores or any cookout materials being used during the test?
We've always wanted to take a picture of this and put someone there roasting a hot dog next to it, but no, we don't have anybody that close.
No. He actually has volunteered. He is for the good of the cause to go out there with the marshmallow and see, how he's going to react to it.
I hear this is very flame retardant.
Your smock is flame retardant.
Yes. No max material, right? Just like the astronauts did.
I have come out here before after a test, and it's kind of interesting. Your flame's gonna go out at angles and wide. But there was a bush here once, and it was this nice big green bush. Half of it was black and burned away, and the other half was just fine.
Oh wow!
So very clean, precise burn from the rocket.
So we have to put you at the right angle for the marshmallow.
Yeah, right at the right spot. You gotta cook your marshmallow and keep it small.
Safety first.
Yeah, safety first.
Well, you've heard it from the rocket guru.
Yes, and you're watching NASA Edge, an inside and outside safe look at
all things NASA.